This is the pre-calculus module 1 practice test. I'm going to go through and work this test, all the problems. I'll explain how I'm doing them. So if you're struggling with the practice test, just fast forward to whichever area of the test you need to review, and you can see how I work the problems, and hopefully that'll help you. If it doesn't help you after watching this, get with me. Check with me before you take the test. You know, the practice test should help you prepare for the test. So if you're struggling with this, I want you to understand it better before you take the test. So don't jump right in there if you're struggling here. And remember, you can use your notes on tests and Desmos.com to graph. If you need a graphing program, that's a good one. If you have a different site you like to use the graph better, use that. But let's get started and look at this. Okay, so the module 1 practice test. First thing it says, determine whether the graph is the graph of a function. Remember, for a function, so each x would only have one y. Only one. There would not be more than one y with the same x. Like if we had a table, -2, -1, 1, and 2, if we have this xy table, if this y is 1 and this one is 2 and this one's 3 and this one's 3, that's okay because this x only has one y attached. This one only has one y attached. It's the same one as this one, but it's only one. If I had 2 listed again with another y where 2 had 3 and also had 4 assigned to it, then it would not be a function. So with a graph, we can always just check with the vertical line. If you make a line straight up and down, anywhere along there, if you ever come to a place where it touches the graph twice, which it only hits there, it only touches it one time anywhere I make that vertical line. So that is definitely a function, right? The graph doesn't loop back and have 2 different y's. When this is the x, there's only one y attached. When this is the x, there's only one y attached. So that's fine. Okay, determine the domain. Now, the domain is all the possible x's. What are the possible x's for this domain? 4 over x squared. Are there any x's that are not allowed in this situation? Well, since this is a fraction, on the bottom of a fraction, we're not allowed to have a 0. All right, because that means take a number and divide it by 0, which we can't do. So the only thing that's not allowed is when x squared equals 0. So when x squared equals 0 is when x equals 0. So everything is allowed except for when x equals 0. All right, let's look at this one. Find the range. So the range is all the possible y's. So we have to look first to say, are there any x's that are excluded? Well, we have an x, we subtract 2, and we square it. So the domain is all possible x's, right? We can put any x we want there. We could put -1,000,000. We could put 142. We could put a fraction, put 1/4, -0.5, whatever we want. So there's not a restriction to the domain. But what possible x's will we get when we put all these different x's? Possible y's will we get when we put all these x's in there? Well, let's look at what's happening. When we take the x, we're going to subtract 2 from it, and then we're going to square it. So we could have any possible x, but we're going to square it afterwards, and then we're going to add 2. So when we take any x, whether it's 100, whether it's 0, whether it's -5, we're going to subtract 2 from it. So 98, right? -2, -7. Those are all fine. And then we're going to square it. So what's going to happen when we square it? 98 squared, big number. -2 squared, it's going to be a +4. -7 squared, +49. Whatever number we take, is going to be squared. It's going to be positive. So there's no way we could end up with a negative number here. There's no way we can end up with a negative number coming out of this squaring process, even if x equals 1. All right. So 1 minus 2 would be negative 1. But once we squared it, now we're back to a positive 1. And then whatever, so what's the smallest we can come out of it? When we square something, the smallest number we can come out would be 0 squared, right? So if x equals 2, 2 minus 2 is 0. 0 squared is the smallest possible result of this part of the function. That's the smallest number we get is 0. And then we're going to add 2. So the smallest possible y we would ever get would be 2. There's no way we could substitute an x in there and get an answer that's smaller than 2. So all the y's greater than or equal to 2 is the range of this function. We could have it equal to 2. If it's 0 plus 2, we would have a 2. So 2 is included. We do need the equals part of that. But that is the range of that function. All right, let's move on. Determine the domain of this function. And the function is the square root of 7 plus x. Okay, how are we limited there? Well, we cannot have square root of a negative number, right? That is an imaginary number. It does not exist. For what we need here, the domain has to be at least 0. We can do the square root of 0. That's 0. 0 times 0 is 0. So we can do the square root of 0, but nothing negative. We can't do negative 0.001. So 0 is our limit. So 7 plus x can equal 0. So subtract 7. So if x equals negative 7, we're okay, because 7 plus a negative 7 is 0. But if x gets any smaller than that, if it's negative 8, 7 plus a negative 8 is going to be negative 1. So we're limited to all the x's that are equal to or larger than negative 7. There. X is larger than or equal to negative 7. Just so we can keep that a positive number under the radical there. All right. So determine the intervals on which this function is increasing, decreasing, and constant. So we have this. I'm going to trace it with a red, make it a little easier to see. So it comes here, and then it kind of curves upward, and then continues on, right? And it goes both directions forever, really. So when we check increase and decrease or constant, we're always going left to right, just like we read, starting the left and going right. So this is going up slowly. It's increasing, increases a bunch, then increases. So this is increasing the entire time. Never does it totally flatten out and become constant, and never does it go down. So this is increasing on all real numbers because it goes infinity to negative infinity to infinity. Okay, this says estimate graphically, okay, the local maximum and local minimum of f of x equals f of x squared plus 3x plus 2. So here's our equation. They didn't give us the graph. They want us to graph it and estimate that graphically. So let's pull up a graph of that then. All right, so here is Desmos.com. I'm using this for my graphing. I have typed the equation right here, y equals 4x squared plus 3x plus 2. So if I turn that on, here is the graph of that, and it wants to estimate the local maximum and local minimum. Well, this is the quadratic equation. So it's just going to be a parabola. See, as far as we see, we're all the way up to 400, 500,000. It just continues going up. So there is no local maximum of any kind, because nowhere does it ever peak and you start going back down. But we do have a local minimum, and it's actually the absolute minimum as well. So the smallest point there looks to be negative 0.375 and 1.438. So let's look at our options. This is the local maximum. We know there's no local maximum at all. All right, so the first two we can rule out immediately. So it's got to be one of these two. This has a local minimum at negative 0.4, so they've rounded it to 1 decimal. We have 375. That would round to 0.4. and 1.44. 1.4 and that 3 would round up. So that is the same number rounded. The other one they have is at 0, comma, negative 0.3. Well, we're not at 0. We're not rounding that far. So rounded, this is the same point that we have just rounded to that number. So that is our answer. All right. Number 7. Determine if the following function is even, odd, or neither. Well, remember, the way we do that is we take and we substitute negative x into the function. And if it equals the same thing it started with, then that's even. If we substitute negative x in there and it ends up the opposite of the original, which means every sign would be totally reversed, then it's odd. And if it ends up with something else, then it's neither. So we're going to substitute negative x in and say negative 9 times negative x to the 4th. Got to put that parentheses because x is becoming negative x. Plus 5 times negative x plus 3. Okay, so let's simplify. Negative 9, negative x to the 4th power. So it'll be negative x times negative x times negative x times negative x. Well, if we do it 4 times, it's going to be a positive x to the 4th. 5 times negative x is minus 5x. And then we have the plus 3. Well, how does this compare to the original? That's exactly the same, negative 9x to the 4th. This is switch signs. It's the opposite sign, and that's exactly the same. We didn't end up with the exact same thing. We didn't end up with the total opposite. If there's total opposite, then this would be positive, this would be negative, and this would be negative. So we ended up with something else. Neither. It's neither even nor odd. All right, let's see what we need here. F of x equals 3x plus 6. G of x is 2x squared. And then we have to find fg of x. When they're together like that, fg, and then parentheses, that means you're multiplying f times g, right? Just like if we had 3x, that means 3 times x, right? So fg, multiply them together. So we need to take 3x plus 6 and multiply it by 2x squared. That's taking f times g, fg. So 3x times 2x squared is 6x to the 3rd. And then distribute this also. 6 times 2x squared is 12x squared. And that's it. We had 2 terms and 1 term. So that should be our answer. No, no, no. There it is right there. The last choice. All right. Now, f plus g of x. Okay, so 3x plus 7 added to 3x minus 7. Okay, this is when you substitute an x in there, you have to multiply it by 3 and then add 7 and then take the square root of that. This one, you take 3 times the x and subtract 7 before taking the square root of that. So these are not like terms. We can't say this is like 2 3x plus 7s or 3x zeros or, can't combine those because they're not the same. If this was a plus, we could say, yes, I have 2 times 3x plus 7 because I have 2 of them. But that's not the case. This one is not a plus. So there's no simplifying that. There's no way to simplify it. It's just 3x plus 7 plus 3x minus 7. Square root of both of those. Square root of 3x plus 7 plus the square root of 3x minus 7. That's as far as it simplifies. All right, this one they want us to find f of g of x, which means we take g of x, which is, you see it inside the parentheses there, and we're going to substitute it in for x. Whatever x is, we'll take g of x and substitute in for it. So since this is g of x, we have x squared, so we're substituting in for that. Square root of x minus 2, that's the x, and it's squared because the x is squared, plus 3. Okay, so what is the square root of x minus 2 squared? Well, the square root and square are inverse operations. They cancel each other out. Just like if we have the square root of 16 and we square that, that's the same thing as saying the square root of 16, which we know is 4 squared, which is the same thing as 16. Notice they can't, 4 squared is 16. So it's basically just canceling these out and just keeping the original number, 16. So the square root of x minus 2 squared is just x minus 2 plus 3. So if we simplify that, it's x plus 1. There's our answer, x plus 1. Number 11. Find f of x and g of x so that the function can be described as y equals f of g of x. So if this is the y, so if this is f of g of x, and it's 4 over x squared plus 9, that means we took g of x and we substituted into the f, and we ended up with that. So what's the possibilities? X plus 9 and substituting in this. So if it starts at x plus 9, we substitute this in for the x. So that would make it 4 over x squared plus 9. Hey, that works. It looks like it's that one. I'm going to go ahead and double check some of these others. This says f of x just equals x. So if we substitute this in, it'll be 4 over x plus 9, because we just substituted all of this for that x. Well, that's not what we were looking for. How about this one? 1 over x. Well, if we substitute that in, it's 1 over 4 over x plus 9, which is certainly not going to be the same thing as this. When we simplify this, no way is it going to end up 4 over x squared plus 9. So that's totally out. And this one is 4 over x squared, and g of x is just the 9. Well, if we take this and we substitute it in for x, that's going to equal 4 over 9 squared, which is 4 over 81. 4 over 81. We don't even have a variable left in the answer there. It's actually a number. So this is the correct answer right there, because that's the only one that gets us back to the original problem they wants to end up with. Okay, find the inverse. All right, so remember, with the inverse, we rewrite this. We take the f of x out, and we make it the y, 3x minus 2. Okay, so this is the same thing. I just wrote it as a y instead of in function notation. Then at this point, we take the two variables, the x and the y, and we just trade places. So the x becomes over here, and the y moves over there. Right? X equals 3y minus 2 instead of y equals 3x minus 2. And then we solve it for y. We put it back to a y equals like we started with. So we'd have to add 2 to both sides. So this becomes x plus 2 equals 3y. And then we need y by itself, so we're going to divide by 3. Divide by 3. So y equals, I'm just reversing them, x plus 2 over 3. That's the inverse of this one. These are inverses. X plus 2 over 3. It looks like this first one right there. And that's inverse notation, right? F of -1, the -1 up there as an exponent. That's the inverse notation. That's not saying take f to the power of -1. Inverse function of f is x plus 2 over 3. Okay, here's another one. Find the inverse of this one. So again, y equals x to the third power plus 4. So we're going to rewrite that as x equals y to the third power plus 4. Solve that for y. So we subtract 4. X minus 4. We can't combine those because this doesn't have an x. Equals y to the third. So to find y, when we have y to the third power, we have to take the third root. So this is the cube root of x minus 4 equals y. These cancel each other out. The cube root of something cubed is just the original number. So this is what it equals to. Y equals the cubed root of x minus 4. Minus 4 times the cube root of x. No. Cube root of x minus 4. Hey, that's it. This one's plus 4. So that is the inverse, the cube root of x minus 4. All right, number 14. Find the inverse of this one. So y equals 6x to the third minus 3. So we'll make it x equals 6y to the third minus 3. All right. Now we'll add 3 to both sides because we're trying to solve for y. So we have x plus 3 equals 6y to the third. Next thing we need to deal with is the 6. So x plus 3 divided by 6 equals y to the third. So that means y would equal the cubed root of x plus 3 over 6. All right. Cubed root of x plus 3 over 6. This one's minus 3, wrong sign. This has the 3 outside. That's our answer. So since they have an inverse function, then they are 1-to-1. They're 1-to-1. Says determine this function is 1-to-1. Basically, does it have an inverse function? So the way we check to see if something's a function is with the vertical line test, right? To figure out if it's a 1-to-1, which means if we do the inverse, is there an inverse function? We have to do a horizontal test, right? So if I draw a horizontal line, I'm going to do it with a blue pen here. So if I make a horizontal line, it should only cross through the graph one time if it has an inverse function, if it's 1-to-1. But the problem is this one, the graph touches there and there. So this one is not, it is not a 1-to-1. So that means if we take the inverse of it, it will not be a function. There'll be more than one y for each x. Because when we do it, remember, it kind of reflects over this line y equals x. So its graph will end up looking like this. And it would not pass the vertical line test after its inverse is correct. Okay. Number 16. Describe how the graph of y equals x squared can be transformed to the graph of the given equation. So how do we make the graph of x squared look like the graph of x squared minus 14? Well, anything that's out here at the end, it's just a constant. How does it affect the graph of the function? This affects the y. It moves it up or it moves it down. A constant outside at the end. So since this is a negative number, it's going to take the original x squared and it's just going to shift it down 14 units. Right? Plus would shift it up, negative shifts it down 14 units. But number 17, how is the graph of y equals x squared transformed to be x minus 14 squared minus 9? Okay, so we know this. We just talked about that. That's going to shift it down 9. So let's see. Left 9, up 9. Down. Okay, so those two are wrong. We know it's down 9. It has to be one of these. So this negative 14 in parentheses. So it's taking the x and it's doing something with the x. It's either moving it left or right because it's shifting the x. But is it moving it right 14 units or left 14 units? This kind of works the opposite. We think of negative would move it that way, but it doesn't when it's inside the parentheses. This is the negative. It's going to move it right. Because if we want to get back to the original x, we got to subtract 14 to get back where we started. So if it's a negative, it shifts it right. If it's a positive, it shifts it left. So since that's a negative, it's going to shift it right 14 units. And then this negative outside by itself is down. So pay attention to those. They work a little differently, whether it's inside the parentheses with the x or it's separately. All right. How do we transform the graph of f and the graph of g? If f is x to the fourth and g of x is negative x to the fourth, what's going to happen? Is it going to reflect it across the x? Is it going to shift it down 1? Is it going to reflect it across the x and then the y? Or is it going to shift it across the y? Well, let's look at real quick just a couple of numbers. Let's say we had a table, x, y, without graphing it. We can say if it's negative 1 to the fourth is going to be 1. right? And then 0, and then 1 to the 4th is 1. So that's how it would look, right? It would look 1 right there as the x is on the graph, right? 1, 1, and negative 1, 1, and 1, 1, and then 0. If it's negative x to the 4th, that means we put a negative out front of everything. So negative 1 to the 4th would be 1, but then we put a negative out there. 0, there's no such thing as negative 0. So these two become negative ones instead of positive ones. So what's happened is we've reflected it over the x-axis, right? Because that's the x-axis. Instead of going up, now they're all going down because all these become negatives. So this is going to reflect it across the x-axis. All right, let's hear. A transformation of f to g represents what kind of stretch? If it was the square root of x, and now it's 6 times the square root of x. So, right, so if we have our x's and y's, and we got our x's, and we calculate, and this y ends up to be negative 1, or ends up to be 0, it ends up to be 3, whatever it is, we're taking that times 6. Right? So what it does is, instead of being graph here, it's making it a lot taller or a lot smaller. So it's stretching it up and down. That's a vertical stretch, When it's multiplying it out in front, it's going to make it a vertical stretch. So, all right, our last problem. Confirm that f and g are inverses by showing that f of g of x equals x and g of f of x equal x. So let's take first f of g of x. If I have x to the third, instead of x, I'm going to take this and substitute it in for x. So I've got the cubed root of x minus 4 to the third power. See, I took this and I substituted in for x, so now it's that to the third power. So you can see it's a 3 plus 4. This is f of g of x. So what is the cubed root of x minus 4 raised to the third power? Remember, those cancel each other out. So that just leaves it to be x minus 4 plus 4. X minus 4 plus 4 is just x. So f of g of x equals x. Now let's go the other way around. Let's take this and substitute it in for that x. So g of f of x equals the cubed root of x, which is going to be x to the third plus 4 minus 4. So let's simplify. I have parentheses in there, but there's nothing being multiplied but a 1. So I can simplify that to say that's the same thing as the cubed root of x to the third plus 4 minus 4. Just removing the parentheses. So now that's the same as the cubed root of x to the third, because plus 4 minus 4 is 0. So what's the cubed root of x to the third? Well, again, they cancel each other out. That equals x. So this equals x. This equals x. I have confirmed that they are inverses because I showed they are both equal to x by substituting in and simplifying down. And I end up with that on both. That's it. That is the practice test for pre-calculus. So if you have any questions on that, get with me. If you do that, you feel good about it, move right on and take the test. You have until Sunday to finish those. So do work you can be proud of.
Let's get out of here. Word to your multiples. Math